Welcome back, reinforcement learning. This session I explained the Q function. Okay, last session I explained the how to predict the future rewards by using policy functions and value functions. I introduced the Q function also. Okay, this session I explained the Q function. The Q function is play the central role in reinforcement learning to predict the future rewards in a state by taking some action. This is the Q function role in reinforcement learning. It predicts the future reward in a state by taking some action. The Q function is represented by using Q letter, the capital Q, of the state S by following some policy pi. Pi is represent the policy. Okay, Q function is depend on state and state. What are the possible actions in that state by following some policy. The policy is strategy, that is the mapping between states and actions. In Q function, the key concepts we are using the Q function is state, policy, reward and action. Okay, state we are representing as policy pi, reward R, action A. Okay, state, the state is information. Okay, it is received the agent to take the action on some environment, that is a state. State is the information that our agent received and use that information to make a decision about what action it should be take. Okay, that is the state. State give the information to the agent to take some action, to take the decision to apply some action on that environment. Okay, for example, raw pixels of a video game is the state and sensor data is the state of the autonomous vehicles. They are represent the autonomous. Okay, in grid world game, the states are the positions of the positions in a grid world game. Okay, this is the grid world game, the simple grid world game. This is the simple grid world game setup. There are the number of positions available here. The agent must navigate along the shortest path to the goal tile, that is the plus is the goal tile, and avoid the failing to the fall into the pit minus symbol. Okay, agent go to the plus symbol without touching the negative minus symbol. Okay, here A is the agent, W is the wall, minus is the pit, plus is the goal. This is the environment, and position of this grid world game is the state. Okay, where you are, which position, that represent the state of this grid world game. Okay, the state gives the information to the agent about the environment. Next one is policy. Policy is a strategy, that is a mapping between actions and states. Okay, policy we are denoted with the pi, the strategy our agent follows when provided a state. Okay, for example, blackjack game. In this blackjack game, the policy is which action we are taking in that state. For example, at the state in this game, which action we take based on the situation, it gives the for example, the better policy is it gives the better rewards. Okay, the state and action mapping is a policy. The reward is we are agent receive the feedback from the environment after applying the some action, that is called a reward. Okay, in chess game the reward is +1 when it perform the action that leads to the checkmate of the other player. The -1, for example, the reward is -1 when it is checked by the other player and there is no other actions are represented with the zeros. The reward is received the feedback from the environment by applying some action to the agent. Okay, next action. Okay, fourth element in Q function is action. We are agent is applied the actions, a series of actions on the environment based on the policy of the states. Okay, here state S1, agent apply the action A1, get the reward R1. Okay, some time slot T, the state ST, the action AT is applied, get the reward RT. Okay, this is the actions every action the agent receives the some reward, and this action affect the environment to change the state of the environment. The state value function, also called a value function. The state value function gives the value of the state, the how much far it how much it is close to the target goal. Based on that, it has the state value. The state value also called value function. The state value is predicted the expected reward by using state only. Okay, that is the value function. Next, our function is Q function. The Q function predict the rewards based with state and the state corresponding actions. That is the Q function. The Q function is represented with the Q pi with the state and A. It expected the rewards based using the actions available on the state and based on that policy. Here the Q function it says that the value of the state is only high if our policy here the value of the state is equivalent to the value of the highest action taken in that state. Okay, the value of the value function and the Q function both are so the predict the rewards. The value of the state is equivalent to the value of the highest action taken in the state. Okay, if the blackjack game, if we are in the state of the having the card total of the 20 and we have the two possible actions, either hit or stay, the value of this state is only high if your policy says to stay when we have the 20. So here what is the highest action? The stay is the highest action. The value of this state is equivalent to the value of highest action taken in that state. In that state, which action gives the highest reward, that is the value of the state. We are using the Q function in Q learning. We are using the Q function in Q learning. The Q learning is a method to learn the optimal Q function. To learn the optimal Q function. Optimal Q function means it gives the best rewards to the states. Best rewards to the states with the best actions. So the Q learning is a method to learn optimal Q functions by using best actions of the best states in flow of the reaching the target. Okay, that is the Q learning. Okay, we will discuss the Q learning in later topics detailedly. The Q function, the starting is 2013 evaluation. If we are using the Q function deep in a Atari, playing Atari with the deep reinforcement learning, in 2013 they presented the using the deep neural network to approximate the Q function. Here use deep neural network to approximate the Q function, significantly advancing the reinforcement learning applications. Here the deep Q network or DQN is, we are using the deep neural network to approximate the Q function, that is called a deep Q network or DQN. We use deep neural network to approximate the Q function is called a deep Q network or DQN. The DQN is we are using in reinforcement learning very frequently to solve the advanced problems. So what are the applications of the Q functions? The Q functions we are using in different domains like games. We are using the games like the grid world games. We are using Q function help the agents to navigate efficiently by learning the optimal path based on the rewards. And robotics, it helps robots determine the best actions to complete the task. And in autonomous driving, it assists the self-driving cars or self-driving vehicles in learning optimal driving behaviors. Driving behaviors means optimal driving decisions based on the rewards from the actions. This is the Q function is we are using in many reinforcement learning problem solutions. Okay, it predict the best rewards of the states with the best actions. So with the Q function is a very important reinforcement learning to solve the advanced problems. Thank you.